Hey everybody, welcome back to Decode Tech. So this video is going to be a big one because it's a topic, at least it seems to be a topic that trips up a lot of people that are new to programming, and it's kind of this way of thinking that can be hard to get your mind around, at least without working with it for a while. And it is the topic of object-oriented programming and objects. So these objects are really just ways for us to model the real world and to encapsulate some functionality directly to some of our data. Essentially, it allows us to create our own types, just like integers, strings, lists, and so on. To see what I mean by this, let's head over to VS Code. So I thought a way to show you how to use objects would be to try to model a real-world situation, such as making a cup of coffee. For some reason, programmers and coffee tend to go together. Don't worry if you don't like coffee, you can just find some for other highly caffeinated drink to keep you awake. So pretty much everything in Python is an object, and we said that objects have methods, which are just functions tied to that object. But other than that, we haven't looked at what objects are too much. So just like we could create our own functions, we can create our own objects. So I have a file makecoffee.py, and let's say I wanted to make some coffee. First of all, a coffee maker would probably be a good idea, as well as some coffee beans and a coffee mug. So to begin an object, say we want to make an object for a coffee maker, we use the class keyword instead of the def keyword. Then, just like we have the name of our function, we have the name of our class. And by convention, class names in Python start with a capital letter. So it would be like coffee with a capital C, and then if there's another word, you just start with another capital letter, like a capital M for maker. Now, a function requires you to have open and close parentheses after it, but a class does not. It's kind of optional. You can put them there, or you don't have to put them there. And then it ends with a colon, which naturally means a block of code is coming. And just like with a function, you can put the pass keyword there, and you essentially have a class defined. Now, that is just defining our coffee maker class, or like a blueprint for our object. Just like when you define a function, that's not actually going to run any code, that's just going to define it. And with a class, instead of calling it like we call a function, they call it instantiating an object. And oftentimes you'll save this object to a variable. So what I'm just going to do is say maker gets coffee maker, and then open and close parentheses. You do need them here when you're instantiating an object, even though you don't need the parentheses up when you're defining the object. We'll look at what those parentheses are for in a later video. But the parentheses down here are kind of like when you call a function, it's actually executing that code and making an object for us. So now maker is a variable storing a coffee maker object. And to prove that, I'll come down here and I'll print the type of maker. Then I'll save and I'll go down to my terminal and I'll run python make coffee. And turns out my descriptions appear through an error. So I'll comment them out and we'll save and rerun. And now you see I get class of main.coffeemaker. That's the same as doing something like print type of 5, which we know to be an integer. And now I'll save and run this. And you see we get class int and class main.coffeemaker. And that double underscore main, you can know, is the name of the file that we're running. And if you saw my video on if name equals main, that explains that concept. Anyway, just showing you that we did make our own object. Now, dictionaries were data structures that you were able to map one value to another value with key value pairs. So like somebody's name with their phone number. But sometimes we want to put some more complex functionality in a type, where we might want to store several what are called attributes of something. And these attributes are like descriptors. So if we were working with a person, we'd describe them. Like their hair color is an attribute, their height might be another attribute, and their weight could be another one. And all these attributes are variables. And a dictionary does not make a good way to collect all these things together. So that's where an object comes in. So an object has attributes, which are just variables, and it also has something called methods, which are just functions. So an object is made up of attributes and methods, which are just really variables and functions tied to that specific object. Now I'm going to move that to the top under a comment, just so you can reference that. But what does that actually mean? Well, both of these things are tied to an object with the dot syntax, and we saw this with a list. Say I had a list called myList. My list is now storing a list object, just like maker is storing a coffee maker object. And then we could do things to our list with methods that were tied with it by going mylist.append. So the append function is tied to the mylist object. and it directly modifies that specific instance of a list. And the instance is my list, whereas maker is our instance in our custom object. And you can make as many instances of these objects as you want. That's one of the key features of classes, is you can make as many objects as you want from them, therefore making your code really reusable. So let's get rid of this example. Now an attribute we said is tied to an object, but it's just a variable. So what we could do is say maker, which is storing our coffee maker object, dot, and then the name of a variable that we want to tie to this object. So say we want to have our coffee maker have a water level, because oftentimes you have to put water into a coffee maker to make coffee. So I'm just going to say maker dot water underscore level. So that's just like a regular variable name, space, the assignment operator, and what I want the water level of this maker to be. Well, when you first buy it, it's probably just 0. So now water level is tied to our maker object, which is a coffee maker instance. So now I can do something like print maker dot water level. And if I save that and run that, you see we get 0. So that variable is tied directly to our object. So often what's used instead of assigning these attributes after we create the object is to have some attributes created right away when you create the object. And to do this, we utilize a method. And this is a special method built into Python, and it's actually called automatically when you create an object. So we're actually just overwriting this method. It's there whether we put it there or not. But when we put it there, we can add our own functionality. So since this method is really just a function, we start it with the def just like we would any other function. And this is a special method, just like we saw special variables with the double underscore name. So this is going to have a double underscore, but this one's called double underscore init. And since it's a function, it needs parentheses after it. And this can really trip you up. Make sure you have 2 underscores before and after init. Now the first argument functions inside a class take are self, or is self rather. And don't worry about this self for now. I'm going to go into detail explaining this better later. That's all you need, then your colon at the end, space, and your block of code. Now I can say self.waterLevel right inside this class, and I can say get 0. So this init stands for initialize. So whenever we initialize an object or instantiate an object down here, its water level will be set to 0. So I no longer need this line of code. It's done automatically when the object is created. So now if I run the code again, we should get the same result. And we do. But notice we can make multiple objects from this class. This class up here is going to be the blueprint, and these down here are going to be the objects we make. So let's make another maker. I'm going to just say another maker, very original variable name, and assign it to another coffee maker object. Now these are 2 completely separate objects. They're the same type, but they're 2 different objects. For example, you can have 2 different lists in your Python script, and if you append to one list, it will not affect the other list object. So now both coffee makers have a water level of 0 because all coffee makers need a water level. So now if I come down here and I print out the water level of another coffee maker, of course I have to rename the object I'm calling the attribute of, and save and rerun. They should both be set to 0 because every time we make an object, they automatically get that water level. And you see we get 2 zeros printed to the screen. I'm just going to clear my console. Now we can still modify these attributes outside of the init function or method. So I'm going to come down here to another maker, and I'm going to call the name of the object I want to modify, and I'm going to say dot water level. Now I'm going to change its water level to 10. Let's say that's the fullest you can make it. So I just filled up this coffee maker. So you can picture someone pouring in water into the coffee maker. Now you can probably guess, but if I print out another maker.waterLevel down here, it'll be 10. But maker.waterLevel we did not change, so it'll still be 0. Further proving our point that these are the same type of object, but they have totally different data associated with them. So let's run this and see if we're right. Sure enough, we get 10 and 0. But now I want to show you that we can actually make it so that when we create the object, we can choose what water level we want this attribute to have. So up in our init method, just like other functions in Python, you can take in arguments so that you can use them inside your function. So I'm going to say comma and water level. Now instead of hard coding water level down here to be 0, I'm going to take that passed in value to whatever we pass it and set self.waterLevel equal to water level. It's probably going to look a little weird at first, but basically what this gives us the ability to do is say we want this coffee maker to have the water level of 0 and this coffee maker to have the water level of 10 right when we instantiate their objects. Then I don't need that extra line there because this 0 is going in as water level and getting set here to self.waterLevel. So essentially what's happening with this self is it automatically gets passed into the init function whenever it's called. And the value it gets passed is the name of the object you're calling the init function on. So when we initialize maker by instantiating coffee maker, it calls the init function automatically and it takes the name of the object, which is maker in this case, and passes it in as self. So it's essentially saying maker.waterLevel gets whatever water level we passed in, which is 0. Same thing for down here. When we instantiate the next coffee maker, it calls the init function again, and it passes the name of the object, which is another maker, passes it in as self, and essentially says another maker.waterLevel, and sets it to whatever the value we pass in, which is 10. So the self is kind of like a variable placeholder for whatever the name of the object we're working with is. So let's run this code and see if it still works. I hit enter, and sure enough, we get the same result. And to help you see this self thing a little bit better, if I take out the 0 here, it's expecting a value because we're asking for a water level. So if I try to run this code, you'll see we get an error that init is missing one required positional argument, water level. Why doesn't it say it's missing self? Because self is automatically passed, which is maker in this case. And so it says we're missing water level. So we need to put a 0 in there for the water level. Now, sometimes I think this doesn't make it very clear what we're trying to initialize here. And if you have multiple attributes, you might not remember the order you define the attributes in, especially if the class definition is in another file or another module, as we learned they're called. So what I think is good to do is to actually say water level gets 0. That way we specifically say, this is what I want the water level to be, and it's very readable code. And then it allows you to pass in these values in any order you want. And I believe I covered that in my functions tutorial. So you can go take a look at that if you're confused by what that is doing. And of course we can do the same thing down here. And I'll run the code again just to prove that it's doing the same thing. And it is. So once again, let's try adding another attribute. Remember, an attribute is just a variable that describes something to do with the object. So we're trying to make a coffee maker object. So what else does a coffee maker have? Well, how about the size of the coffee cup you want to make? So let's do self.cupSizes. And now what might be a good way to store cup sizes? Well, normally they have multiple sizes. So if we want to store multiple values, maybe a list would be something that would be a good way to store these. But will they ever change? Will we ever be able to make different sizes of coffee? Probably not. Probably your coffee maker will come with like 3 buttons or so that has a small, medium, and large size cup. And that's all the sizes you'll ever be able to make. So maybe a tuple would make more sense, since a tuple is more performant if you know the data is not going to change. So let's just type in small, medium, and large. Of course, we have to represent this data in some Python recognized data, so I just used strings. So since our description or blueprint of a coffee maker now includes cup sizes, both of our coffee maker objects or instances have this cup sizes attribute, because they're both coffee makers. And in this case, I hard-coded this tuple in because all this kind of coffee maker are going to have these 3 sizes. You could, if you wanted to or thought it made sense, do the same thing we did with water level and let an argument be taken in to decide what cup sizes are available. I'm going to save and run that, and you see we get the same result for both of them. And since this is really just a tuple, it means this whole statement where this whole expression evaluates to a tuple. If we wanted each value one at a time, we could simply just use a for loop. So I could say for cup in maker.cupSizes, print cup. Now I'm going to go ahead and run that, and see we get small, medium, large one at a time. So these Python fundamentals or programming fundamentals keep coming through over and over again. So you can see how this coffee maker is really starting to take the things we've learned and kind of package them together in a nice object that can act like a coffee maker in the real world would. And once again, just to clarify, this code down here is the code actually making the coffee makers, and this code up here is just saying what the coffee makers will look like when they're created. This is the class, this is the object. And notice the objects start with capital letters. That's how you can tell it apart from a function like the print function, which starts with a lowercase letter. So functions are a name with open and closed parentheses, but the name is lowercase, and an object has a name with a uppercase first letter and open and closed parentheses. Now I know the built-in objects aren't created the same way. Like lists, you can make square brackets, for example, or integers, you can just type 5. As far as I know, we don't have the ability to make syntax quite like that to create objects. Most times you'll be seeing syntax like that for custom objects. But if anybody knows of a way to do that, please leave it in the comment section down below because I'd be interested to see it. But I want you to note we really are doing the same thing. Either way, we're just creating objects. Now, I said objects are made up of attributes and methods. We looked a good bit at attributes and we looked at a special method. But now let's look at some of our own methods we can add to our class. So these methods are really like actions associated with the object. Well, what's an action we might want to be able to do to our coffee maker? Well, if our coffee maker has a low level of water, we might want to be able to refill it. So what if I made a method called refill and added the functionality to do that refilling? So I'm going to come down here and I'm going to backspace to the same level as our init function. So we're still one indent inside our class, but we're not inside the init function. We're directly in line with it. And I'm going to do def again to define another function because a method is just a function. And I'm going to call it refill. And it needs open and close parentheses. And functions inside a class take self as a parameter. And then I'm going to do a colon and hit enter. And now we want to do the functionality for refilling this coffee maker's water. So we could get really clever and really fancy with this refill method, but really the simplest way of showing or representing refilling this coffee maker is to up its water level attribute. But to do that, we kind of need a max water level so we know how to fill it up full. So I'm just going to go back up to our init and I'm going to define a self.maxWaterLevel. And once again, you could let this optional to whoever creates a coffee maker object, how much water they want this thing to hold. I'm just going to use an integer to represent fluid ounces, and I'm going to do 32 fluid ounces. So then what I'll do in my function is I'll say self.waterLevel, and I'll reassign it to have the value of self.maxWaterLevel, because we're assuming if we're refilling it, we're going to fill it the whole way up. Now I know not everybody always refills the coffee maker the whole way up, but let's just assume for simplicity that they fill it up to the max water level. Now a good rule of thumb to know if you're using a method right is if you're using the self inside the function. So notice we're taking in self here to know which object to modify, and then we're using that to say take this object's water level and increase it to the max water level. So now I'm just going to back this code up a little bit so we can see more, and I'm going to get rid of our looping over the cup sizes. Now let's say I want to refill our coffee maker that is stored in the maker variable. So I'm going to call the object I want to modify, which is maker, dot the name of our method we just created, which is refill. And you see VS Code actually noticed it for me this time. And since it's a method, this time I need open and close parentheses. Now self automatically gets passed. And remember, self is just the name of the object. So maker is kind of taking a dive into our function, and it's now saying take in maker up here as self. Maker.waterLevel gets maker.maxWaterLevel, which will be 32, because any coffee maker object you make will have the max level of 32. So let's see if that method actually refilled our maker by printing out maker.waterLevel. And just to prove that it's different from another maker's water level, let's print another maker.waterLevel. I'm going to save. I'm going to run this code. Now you see we get 32 for the refilled one, and we got 10 for the one that we instantiated with 10. And we know that we did change maker's value because we instantiated it with a value of 0. So this, in essence, is what an object is. It has attributes, which describe it, and then it has methods, which allow you to interact with it. And the whole point of this object is to model the real world and make it easier to work with our data. What you need to realize is you don't need an object to do anything. You can do anything you can do with an object without an object. It just might take more code, might be a little harder to follow and to organize. So I would say don't stress over these objects right away because they are kind of a hard concept to get, but they are everywhere. People use object-oriented programming all over the place, not just Python. So it is a really valuable concept to know. And one last thing I wanted to show you was making a module to store our class definition. Just like we had made a math module to store some basic math functions, you can also store objects in modules, or rather class definitions in modules that you can make objects out of later. So modules often have a collection of objects and functions related to one topic. So we're talking about coffee, so I'm going to make a new file, and I'm going to name it coffee.py. And I'm going to take my definition of my class, which is up here under my class definition. I'm just going to cut it, go over to coffee.py, and paste it. And I'm going to save that. I'm going to go back to make coffee. Now I still want to be able to work with my coffee maker objects, so I'm just going to say from coffee.py, or sorry, just coffee, you don't need the file extension, import the name of my object, which is coffee maker. Now I've imported coffee maker into my namespace. And if you don't know what this from statement is doing, or namespaces are, you can check out my videos on modules where I explain that in detail. So this code should work the same now, and I'll run it again, and it does. And one last thing to make this tutorial feel more complete, I told you that often it's wise to make a main function for your program. So let's define a main, or a function called main, and let's take all this code and let's just indent it inside that main function. And now let's finish it off by at the bottom saying if _name equals the string of _main. And if you don't know what that does, go ahead and check out my video called if name equals main. And what I want to do in this case is just run the main function. So I'll save, clear the terminal, and run one more time. And you see we get the same result. So I'd argue that this is pretty decent Python program structure. So I hope this made sense. This has been an introduction to objects and classes in Python. If you liked it, please give it a thumbs up. Also, please consider sharing it with your friends. And if you subscribe, it'd really help the channel out. Leave any questions or comments down below, and we hope to see you all in the next video.